Dobar dan. Sa ovih akademskih 5 minuta mi možemo započeti današnje predavanje. Poštovani akademici, poštovane kolege i kolegice, dame i gospodo, poštovana članovi obitelji naše nove dopisne članice. Drago nam je da smo se okupili u ovakvom velikom broju na prvom predavanju nakon nekoliko godina. Ja se ne sjećam kad je bilo prvo. Profesorice Danice Kragić Jensfelt, koju je naša akademija izabrala za dopisnu članicu na zadnjem izbornom zasjedanju. Nekoliko riječi prije nego što predam posao našem akademiku Petroviću, koji će vas voditi kroz ovo predavanje. Samo Hrvatska akademija znanosti i umjetnosti uz redovite članove koji žive u Hrvatskoj bira i dopisne članove koji rade vani. Naravno, kriterij je dosta jasan, istaknuti znanstvenik. Međutim, za dopisne članove imamo još jedan uvjet, a to je znanstvena povezanost sa Hrvatskom. S hrvatskim sveučilištima, znanstvenim institutima i hrvatskim znanstvenicima. Evo, s takve kriterije nama je posebno drago da je prošle godine za dopisnu članicu izabrana profesorica Danica Kragić Jensfelt. Profesorica Kragić je i članica Švedske Kraljevske akademije znanosti. Imamo neke sličnosti u organizaciji, tako i u Švedskoj akademiji postoji razred za tehničke znanosti. I profesorica Kragić predsjeda u ovom mandatu u Švedskoj akademiji tehničkim znanostima. Ne bih duljio dalje, jer nam sigurno čeka zanimljivo predavanje, pa molim akademika Petrovića da krene sa uvodom u predavanje, predstavljanjem naše dopisne članice i idemo na posao. Izvolite.
Hvala lijepa. Baš mi je drago vidjeti vas u ovako velikom broju. Veliko mi je zadovoljstvo i čast reći nekoliko uvodnih riječi o Danici. Ja ću biti vrlo osoban danas, nemojte se ljutiti, jer Danica i ja surađujemo već 20 plus godina. Životopis ste vidjeli, rođena je u Rijeci, završila tehnički fakultet u Rijeci strojarstvo, a profesorica je na računarstvu u KTH. Znači, to je malo kod nas, recimo, neobično bi bilo, ali evo, nije baš sasvim neobično. Dakle, samo ću reći njenog životopisa dobitnica 3 IRC granta. Više neću o tome govoriti i još samo 2 reći, kako se to kaže, štikleca, što bi rekli ovdje iz naše suradnje. Prvi štiklec, projekt Centra izvrsnosti za napredne autonomne sustave, kooperativne sustave, kad smo imali 2011. 2015. u rujnu 2014. u Dubrovniku imamo završnu radionicu i sastanak sa evaluatorima koje je imenovala Europska komisija. 6 mjeseci ta evaluacija. Danica je bila predsjednica znanstvenog savjeta tog projekta, ja sam bio koordinator. Danica je 6 mjeseci prije toga rodila i sa njenom kćerkicom Izabel, koja je ovdje, doputovala je iz Stockholma u Dubrovnik i čitavo vrijeme sastanka u kolicima je sjedila Izabel. I bila na sastanku. Drugi štiklic koji ću reći, prije nekog godina za čuli Ministarstvo gospodarstva planiralo raditi, bio je, mislim, ministar, onaj Horvat, tako nekako se zvao, raditi strategiju umjetne inteligencije. I onda se saznali za Danicu, pa ajde, pozovu ih, bio sam tamo na sastanku. Danici nije bilo teško ustati u 3 ujutro, petak ujutro, da bi navečer opet letile i održati, da podijelite neke ideje. Sad, kako je prošao sastanak, bolje o tom ne bih govorio, ali hoću reći Danici na pomoć Hrvatskoj, ovo što je rekao akademik Lovrek, pomoć Hrvatskoj je ona pomoć koja nije kroz medije, da se napada nešto u Hrvatskoj, njega optužuje, već Danica pomaže istinski, onako potiho, onima koje ona prepozna da u Hrvatskoj nešto želi promijeniti. Ja sam spomenuo svoje osobne iskustva, siguran sam da ima još puno iskustava, znam za neke od sveučilišta u Rijeci, pa za djecu, gdje je održala razne radionice, predavanje i tako dalje. Evo, ne bih dalje. A ovo, samo ću još nešto reći, dakle, o Daničinom znanstvenom radu, zapravo što će sve ona sama više predstaviti. Dakle, mi kao ljudi, kad smo djeca, učimo za interakciju. Čitav život učimo da bi mogli s nekim podijeliti nekakvu komunikaciju uspostaviti. Isto tako učimo kroz interakciju. od drugih ljudi. I zato jesmo ljudi i zato jesmo neka zajednica, bez obzira na sve virtualne ove komunikacije, ipak kad se vidimo, dodatni modo interakcije postoje. Sada mene jako zanima gdje smo danas, koje je stanje o interakciji robota, što od tih naših vještina koje imamo mi kao ljudi mogu imati roboti, kakva je tu uloga umjetne inteligencije, između ostaloga, između drugih tehnika i zapravo da vidimo što to Danica i njezin tim rade na tom području. Evo, Danica, izvoli, ne bi duljio.
Veliko hvala Ivane na prezentaciji. Ja uvijek budem sva crvena i evo jesam već. I veliko hvala akademiji. Hrvatski su me mediji pitali na koji način, da li mogu na neki način sumirati koji je osjećaj biti dopisni član akademije. Onda sam rekla, ako moram izabrati jednu riječ, onda ću reći nestvarno. Jer ja uvijek u sebi razmišljam kao nekome koje iz ovih područja. Otišla sam davno, ali nema veze, stalno se vraćam. Ali onda uvijek u sebi mislim, kad sam išla u osnovnu školu i tako dalje, pa su svi pričali o akademicima i tako dalje, sama pomisao da ću ja jednom biti akademik, to mi je bilo totalno nestvarno. Ali evo, tu sam, hvala. I nadam se da će ovaj put biti manje od 10 godina da bude iduće predavanje. Jer tema o kojoj ću danas pričati na engleskom, puno mi je lakše, se razvija vrlo brzo. I mislim da to svi znamo, da umjetna inteligencija, robotika i tako dalje, nekako imamo osjećaj da se o svemu tome sve više i sve češće priča. I kao što si ti, Ivane, rekao, gdje smo i šta nas čeka, ne znam koliko ću uspjeti u nekih 40 minuta pokriti, vidjet ćemo koliko dođemo, do gdje dođemo. Engleski. So I want to go back some years, almost 35 or exactly 35 years. I want to go back to 1989. And at that time I was in Croatia. It was the last year of my high school. And we had a high school project. I don't know whether that's still something students do in high school. But we needed to make a high school project. And together with my two friends, we decided to build a system for automatic noun declension in Croatian language. I suppose that everybody knows what that is. And I don't know if you, when you speak every day, think about that actively, or is just something that is intrained. I made this presentation for people that are not Croatian, so I wanted to give a little bit of explanation, but I think that this audience knows about this. So all nouns, including personal names, you need to declense them, right? And there is a big history and the grammar rules behind this. Why do we declense, how these make sense, and so on. Now, for my husband, who is actually Swedish, it comes very strange that he actually has 6 or 7 names in Croatian, because we do declense personal names, right? And especially if you want to call Patrick and you say Patrice to him, that doesn't mean or doesn't sound anymore like his name. So, Croatian language, I love Croatian grammar. It has many rules. We know that there are rules that talk about the root of the noun, there are endings, there are also very many glasovne promjene. Imamo nešto što se zove nepostojeće a, koji mislim da nema niti jedan drugi jezik, i mislim da je to jedan od razloga zašto je ljudima jako teško naučiti hrvatski jezik, i mislim ako znaju deklinirati, dakle, osobna imena, mislim da su onda došli vrlo, vrlo daleko. Okay, back to English. So why was this interesting? We needed to build a system. Okay, so what we did, we basically used 3 programming or 4 programming languages. We used Pascal, we used Visual Basic, we used C, C++. And the idea was that we built something where it was easy to interact with, so anybody could basically write a noun of whatever type. They could do this in singular or in plural, and there was like a visualizing system that visualized also the rules that actually ended up to basically declense the things. Like a small recommendation engine was also built that we could kind of explain which next words they would use in order to learn more about all this glasovne promjene i tako dalje. Okay, so a question to the audience. What do you think the most commonly tested nouns were? We did collect the statistics. What do you think people wanted to look at? Personal names and dirty words, right? And if you think now about some of the dirty words, I mean, it's horrible to talk about that at the academy, but that's actually the fact. These are the words that do also, well, we needed to actually put them in a small database because they didn't, some of them did not follow the grammatical rules, and there are many other words, which are not dirty words, that do not follow grammatical rules, but it was not really nice, you know, to write those and have them in a small database, but that was the case. Now, why do I talk about this? I talk about this because we had a process, right? We took a book, a Croatian grammar book. We learned everything about the rules, and we built a system that could do this automatically, right? Back in 1989. So it was pretty long ago. But it was a system, and that was a system that did something with text. It was a system that could find things that did not follow a set of rules. And I always think about this, especially when I meet those two that made this with me, which one of them also happens to be a university professor in Rijeka, or who I meet very often. We always ask the same question: how would a typical high school student approach the problem today? Would they go to the library? Would it take a book? Do they understand that there is actually a grammar that can be used and coded? Or would they resort to more a learning-based approach? What would that be? Use something like a ChatGPT system and so on, and try to extract, in the best case, infer not only the examples of the cleansing all the nouns through the, through all those 7 cases, but also potentially try to infer the rules. And is that possible? Is that possible with today's large language models to actually go back to do the reverse engineering and not to go from the rules to the result, but look at the result, look at large texts of data and try to infer the rules. So basically, try to understand the origin of the Croatian language. All that has to do with knowledge representation, it has to do with learning, it has to do with inference, and those things we know from mathematics. But in order to be able to actually build systems, we need to know something about computer science and more. We need to also know something about how contextually the words are being used, when those different cases make sense, when do we use them, how do we use them, and how they actually are used in large corpus of text. Why is this important for today's lecture? Partially because we talk about language versus action, and if we go back to the origins of language, why do we have language, and whether the language would exist if it did not have the body. There are lots of people that believe that we build the language to help us to do more effective interaction with the world, to explain the actions we are doing. So it's very natural that we want to study language and action at the same time, and this is all motivated by the fact that lots of cognitive neuroscientists, philosophers, and so on tell us that language can be learned more efficiently through action. So it is not possible to convey solely language between people without grounding it in action. There have been examples in human history where people have tried to prove that hypothesis. And I'm not going to go into details of that, but putting humans in a dark room without the ability to actually observe their body and try to teach them language without having the ability to ground it in their own actions. Now, I talk about this because many things that we do today with our body, we take for granted. It has taken us quite some time to perfect interaction with the world, to learn how to use the dexterity in our hands, how to use the interaction with the world, without actually being able to convey the metric of the interaction. What do I mean by that? When you fold something, you can't explain how many centimeters you actually fold the shirt with, or the sleeve. You say you take this and put it there, you take this part and put it there. You can't convey how or what type of force or torque you use when interacting with the world, and so on. Why is this important? Well, it is important if we want to actually build machines that we want them to have the equal ability, or similar to humans, or equal, or maybe even better, to execute all these tasks you do on a daily basis many times without your ability to actually use language and metrics of the interaction to convey what and how you are actually doing. But we do learn through seeing and, through teaching kind of like each other's and seeing. We can imitate, I'm going to come back to that. We can mimic. But until we ground it in our own proprioception, nothing of this really can be very extensively, or with the model that we need, can be stored and used in the brain. Now, technically, observing humans has been studied for a really, really long time. We always wanted to understand how humans move, how muscles move, what velocities we use when we do certain things, and so on. And I would say that in the beginning, when we started to study humans and human hand interaction with the world, my own group has been very much interested in just understanding the kinematics. Why do we need 5 fingers? If I'm to build a robot with a hand, do I really need to do a 25 degrees of freedom complex kinematics? Because 25 degrees of freedom, dependent a little bit of how you connect them, will need a lot of actuation. The more actuation you need, the heavier the robot. That we all know, right? So we wanted to understand, by observing humans' interaction with different types of objects, is pinky equally important as your thumb? Do we need a pinky? Do we need an index finger? And I got interested in this partially because of my background in mechanical engineering, because I really wanted to understand if we are to build hands, or if we are to help companies that are building intelligent prosthetics and so on, what is the biggest value for the human that would need to go back and potentially use a prosthetic or a hand, or maybe having a robot that can help somebody to change diaper or dress himself or herself and so on. And the work that we did, I would say now almost 15 years ago, was actually using generative AI. It has been using models that we know from mathematics of being generative type. We have used Gaussian process latent variable models and so on. So everything we hear about generative AI today as being something very new, it is actually not very new. It has been an excellent tool for many of us to really understand the origin of, as I said, physical interaction. But why generative models? Why is this interesting? Well, similarly, as you want to use a generative model to generate text, you also want to use a generative model to generate action, either for the control purposes, for controlling robots to do various types of things when they interact with the world, or maybe for the purpose you want to find a specific type of hand. You want to generate a hand design that could potentially be very useful for a human that potentially drives a car whole day, or potentially types, I don't know, on a keyboard or something like that. So the study that we started to do looked really into what mathematics is necessary and how do we combine it then together with generative type of AI or generative models in order to understand very different kinematic structures. And I always go to mechanical engineering, why, and dynamics of this, because I feel that with machine learning and with data-driven models, very little people or very few people today really want to go back to the origins of the mechanical engineering and try to understand really what are these mechanical systems we wanna control. But what generative models can give us today, what we maybe don't have from what we had previously with modeling these types of systems analytically, is that they give us a possibility to transfer the knowledge between different types of mechanical solutions. So if you assume that each of these systems has some configuration space that can be described by some form of a high-dimensional manifold, right? We have some form of mathematical structure. The idea would be that if we have methods that can bring us or transfer knowledge between these different types of manifolds that describe the behavior of a system, that we can then, independently of learning something on a human-like system or on a robot with only 2 fingers and so on, that this experience or knowledge can be transferred if we have various types of mappings that I will talk a little bit more about. So back in 2012, what we did use data-driven systems. We did record human interactions with different types of robots, with objects. We did use simulation, for those that remember maybe the GRASPIT system, which I contributed to during my postdoc at Columbia University. So simulation was also there. So generating lots of data and trying to really understand how these systems work, we did it already then. What we didn't have was the fact, what we didn't have was the processing power. Really, we couldn't kind of like process this extreme amount of data that today is collected on robots that are on wheels, on legs, that we could entitle or call as humanoid robots or robots that are inspired by other types of biological creatures such as animals and so on. So this is what I would say is a big difference. You can't hear it? Okay. Okay, da me svi čuju ovako. Ok, može ovako. Mislim da se mogu derati da me svi tamo čuju. Ako me ne čujete, onda mi recite. Ok, so what I think is important, and what we did not have back when I talk about like 10, 15 years ago, we did not really have the processing power, and we did not have this large push in the academic society to resort to data-driven methods, right? Because today it is, you can't hear? Ovako? Ok, ništa. Ovako. Pa mi recite ako je prizvuk. Ok. Ok, so where is the motivation coming from? And I think we always need to go back to human, right? Why? Why is this important? Because the things that we are developing today, that we as academics are actually contributing to, is to be used by humans, and it is to effectivize lots of things we humans do in daily basis. And then when we envision all these robots that will help us to prepare food, to maybe clean, or to lift us from the bed when we are like 127, because that will be the age, I think, that we will live. Okay, so I think it's extremely important to then go back and think about how do we humans communicate, how is learning happening in biological systems, and then try to all the time draw a parallel. What is it we are building in more kind of autonomous robotic type of systems, and in which way these systems can communicate some form of internal state. Even I would claim that not in all the cases that we humans find ourselves in, we can always communicate our internal state. Whatever that might be, it might be emotions, it might be more from the proprioceptive point of view, and so on. But what we started to look into, and one of the recent publications basically looked into the capability stack, right? Because right now, the fashion in robotics community is to take a problem and try to collect the data so that you can solve the problem, what is it called, end-to-end, right? So if you just have enough examples, you believe that if you train whatever type of a generative model, reinforcement learning system, diffusion policy, or something like that, you will be able to generalize at whatever level. I don't necessarily believe in that, or we can take away the necessarily. I do not believe in that, because I believe that we have different levels of intelligence. And I do believe that with some of the recent models that we have developed, such as, for example, diffusion policies, we can solve a larger family of problems than we could previously by using control theoretic methods. But this does not necessarily bring us to high level where this decision-making, more contextual reasoning, and so on needs to be done. So how I like to look into it is that there are three levels that we can talk about. We can talk about systems that have the ability to adapt, systems that need to generalize, and then there is emergence, right? There will be systems that have so much knowledge and so much training where new type of behavior, not something that we can even envision, will emerge. And I think that for robotics, that type or that level has always been somehow the goal. So if we build systems that are approximately similar to humans, behave like humans, can adapt and generalize, that these types of systems will also be able to demonstrate the level of emergence, some form of intelligence. So I don't like to talk about human versus robot intelligence. I like to talk about emergent behaviors, because I think that this is something that we humans are really excellent in. But then, given that we are also developing systems that are potentially dangerous, dangerous from the perspective that not that a robot would, let's say, injure a human on purpose, but just because we don't build systems that are that have the interface so that any human, trained, untrained, engineer, not engineer, can interact with, so that something wrong is not emerging, or that the robot is not generalizing to a behavior which is very unexpected. And I think that this is very important, because this is also something that we can't control in humans, right? We can easily be affected in various types of social contexts and so on. We can change our minds. So even if we know and have access to facts, how we act and what type of behaviors emerge, it is actually rather easy, I would say, to control in humans if you have a changed set of values. And I think that this is when the responsibility comes. And this is a little bit next level, something that I think I did not talk about 10 years ago, because I didn't think of it that way. I thought very much about, the guarantees, interpretability. I talk about explainability. We talked about formal methods. So if we can just build systems that kind of, formally or follow some formal rules and so on, that this will be kind of like the solution of having safe type of systems. Now, I'm not so sure anymore, because with the different methodologies that we have access to today that can be awarded and rewarded in different ways, I think that we will need to think a little bit differently. Now, why is it important to talk about this? Well, during the past 5 years, we have been talking very much about large language models, but there are also visual language models that we are now using a lot. And there are initiatives of building other types of sensor-based, let's say, data or huge databases, where robots are equipped with sensing that we humans don't have, right? Visual is one thing, and if we agree, we or a robot, what's in a picture, that's one thing. We read the text, and we can agree that potentially what the text, the meaning of the text is this or that. That still goes well for both humans and machines. But if the robots somehow start to think in some form of a force-torque space and start to talk about forces or torques and builds kind of like some form of values based on the sensing that we humans cannot put any metric value on, this starts to be a little bit of a problem. And why is that? Because this is now the only thing that has not yet been automated. That physical interaction, the ability of these systems to actively, physically change the world. And I think that this is important to continue to kind of like think about. Is it new? Did we know that we are going to come here? Yeah, absolutely. I'm sorry for the resolution of this video, but it's back from, I think that the first paper came out in 2009, so not in 2010, but before that. Yes, we could track human hands in real time, we could understand the interaction with the world and so on. And this is exactly today what is being used to process various type of video information in order to understand human interaction with the world. There are also systems today that can track not only the full pose of the hand, but exactly infer what type of force human is using when he or she is pouring the wine in a glass. And this is really interesting, right? Because this is something that we humans can't actually say. I can't really say if I use 5 Newton or 6 Newton. Of course, it depends on how much wine there is in a bottle. But today, given that we have trained lots of systems on simulated data where that physics exists, you can now infer this directly from visual data. And this multimodal aspect is something that we really need to think about because this is going to continue. And why is that? Well, a couple of months back, well, I'm lying, 6 months back maybe, we started to look into how just the regular game playing equipment can be easily used to actually teach robots how to do something complex. So here is a bottle. It's a single hand. And what one could basically do is to use Oculus Pro system to track the hand and teleoperate the robot hand, so to do something that is rather dexterous. You see how 2 fingers are basically controlling a 4-fingered hand here to unscrew the lock from the bottle. And this is just training data, you know. You can have this in a very nice way. You use the same system that you use as when playing games. And this now information can be used really as the training data to train various types of diffusion policies and have robots learn rather dexterous tasks. I commented when I talked to one of the journalists here that we cannot demonstrate changing a diaper on somebody because that's much more difficult. But again, I would say that with the parallel development of humanoid-like robots and the ability to program them through physical interaction by using gaming equipment, this is going to be less and less difficult. Okay, and this brings us to why I think that I have problems with my PhD students today. And the single sentence that I like to put it in is that things seem easy today. If I go back 10, 15 years, it has taken several PhD students that have, you know, been sitting in the lab for months to code something that would be able to demonstrate a system like this. Track human hand with high accuracy, transfer that knowledge to some form of a robot hand, and demonstrate the completely autonomous behavior after training the system. I mean, this would have taken not only one PhD student, but several of them. Now we have many of these capabilities available for free. If you download them from GitHub, or if you have a good friend that does research on this, it will not be difficult to build a so-called robotic skill learning system. And I think that this is good. It is pushing the science forward. We can go back and discuss what science really here is. but it demonstrates the capability that something can actually be done on these physical systems much faster than we could do before. So just to give you a little bit of a glimpse of what do we do and how do we integrate things, let's see if this plays. You have something like a chat GPT system or something like that. You select the skill. You instruct the robot, you speak to the robot, you say, I'm thirsty, I would like something to drink. The robot can use visual language models. It observes the scene, it answers you, it tells you what's in the scene. And then in the library of actions, it finds the appropriate action to really serve the right, in this case, it will be beer. We have lots of German students. But anyway, one of the things, of course, here, how to open a beer bottle. This is not easy. And you can go home and try to actually have the bottle opener and do it with a single hand, because this is what is happening here. We usually hold it, and then we apply force, right? Here, the robot basically was trained to do it with a single hand. So this is just one example. Then, okay, now I'm hungry. The robot can observe the scene. It can find that there is some rice in the bowl. It can understand that it cannot serve the rice if it doesn't remove the lid. I mean, all of those things, you know, thinking about that, how you just put together large language model, visual language model, and skill learning. This is what you can do in 6 months. If we can now, you know, go back 10, 15 years, this took years. So at least something has happened. Another thing that we can demonstrate is basically learning these skills online. So the system can reflect. It can say that it does not have a certain skill. It can tell you that it maybe needs 100 demonstrations. If you have a skilled PhD student, it will be able to demonstrate things. Let's say, I don't see where my cursor is, but the video is long for those that are interested. Everything is on the web, so you can find it. The interesting thing is that you can provide some demonstrations. It only takes 1 hour to train a new skill and so on. It looks good, and you can publish an academic paper on this at some of the leading conferences and journals in our field. Does this solve anything? Does this make it possible to actually take this robot and deploy it in somebody's home? I would say that challenges are still equally big as they used to be 10 years ago. We do science a little bit differently. We can demonstrate, kind of like the minimum of what we can demonstrate is much higher than it used to be, given the time we put into it. But the big problems are still left to be solved. And this is why I wanted to talk about this, because it boils down to things we do not talk about, right? We still need to engineer the environment a little bit, so even if we can demonstrate the bottle, let me see if this plays, opening with one hand and so on, the bottle is fixed in the table and so on. There are times, of course, where our interaction or text-based interaction doesn't work from time to time. You actually get back an answer in Chinese. And if you just use that to generate a plan, that's not good, right? Because you will break your robot and so on. So there are still many things that need to be fixed in order to have and deploy these types of systems for and in between kind of humans in daily environments. So there are many things to think about. There are very many challenges. What assumptions do we make when we demonstrate things? You know, do we demonstrate also the cases where, well, we demonstrate usually good things. I mean, how to open the bottle, but we don't demonstrate many more or 10 times more ways of how things can go wrong, right? There is no really formal verification, but that's something that can easily, maybe with some formal models, be integrated and so on. There is a lot of use of sim-to-real transfer, but then there are challenges with how do we understand friction, contact, and so on when it comes to especially deformable objects, something that we work on. And of course, there is more and more debate on performance saturation, scaling law, quantization, and things like that, which I think is also going to hit us all very hard, those doing kind of robotics, because I think that we will come again 90%, but those 10% of having robots really in our homes will be very equally to solve, if ever. I'm not kind of like a pessimist, I'm a huge optimist. But I think that the focus of the scientific community right now is in basically just generating lots of examples and hoping that that will solve everything, which I don't believe in. Now, when it comes to then physical interaction and grasping, I do like mathematics, and again, we have during the past 20 years looked into various types of mathematical formulations that allow us to achieve some form of generality or transfer. And this was back in 2012-13 when we started. I said it would be really, really nice if I can somehow mathematically represent a system where I learn potentially how to grasp something that looks like a book, something in the lower left corner, and then I have some continuous representation of stable grasps, three-finger grasps, that would kind of transform as the shape transforms, as you mold the shape of the object continuously. Those three vectors that are actually pointing out are one example of a stable grasp on that object. So think a little bit of yourself when you are blowing a balloon, right? The object changes shape, and then you also sometimes you change the way you hold it. You move the hand and so on in order to kind of like to preserve the physical grasping with the object. When we did this back in 2013, people would come to us and say, it's really nice, but I don't really understand the mathematics. Okay, so we tried to explain this, but still nobody kind of got really interested in this because they felt that, yeah, but it's grasping, we can solve grasping in many other ways, we can do sampling and so on, we don't really need to do this continuous kind of representation. But now I would say that with data-driven methods, we can't still, if you have two objects that are very similar in shape, there is really no continuous kind of like transfer that you can easily do. You know that you can grasp something that looks like this, and then let's say that this object becomes just a little bit wider, or just a little bit higher, or just a little bit thicker. You would still go and sample. You would try to find a new grasp on that particular new shape. You would not go and deform the grasp you know works on this shape, and then try to continuously deform it to a changed shape. And I think that that's a pity, because I think that that's a very nice theory that can be kind of like used and generalized. I will finish and give you time for questions. Why I think that this is important? This continuity is extremely important when we interact with the physical world, because this is exactly what we humans are really good and adapt to. How do you plan how to slice bread? You think of what type of bread you have in front of you. You know which knife to take, with or without teeth. You know somehow how it feels proprioceptively when you apply that force, and then you use the second hand to counter work in a way and to generate forces that are necessary for you to cut. But then even if you never sliced a raw or a cooked potato, right, you will somehow adapt the knowledge you have from bread or from slicing bananas or something like that to the changed state of a cooked or a raw potato. Or you can think of, for example, squash that has been in the refrigerator for 3 days and has a thick kind of like outside, and this is where you will also need a different type of action. So this calls for methodologies that today, to some extent, we don't necessarily anymore need to do with model predictive control, optimal control for that part, where diffusion policies can be trained and are actually very helpful for the purpose to generalize various types of actions. And another example where we can use that is in interaction with soft and deformable objects, because here we also have a big effect on what actions to use if you want to fold something, whether things follow or whether things fall back and so on. I don't have so much more time to go through all the details of how we address maybe some of the theory and how do we go back to these grass modular spaces through equivariance and try to use equivariant representation to understand what under certain transformations becomes, let's say, invariant, equivariant, and so on, and how this can be used for doing knowledge transfer. But I'm going to go to the end and talk a little bit about what's ahead of us and what I think it's... oh, I had too much, sorry. Yeah, two things. One of the recent things that I got interested in is to really try to understand all human senses, maybe not taste for that, but really the smell. And why is this important? Well, I wanted to find something new, so we started to look into human smell. We tried to, together with neuroscientists, understand the effect on human action when things, smell differently. And this is really interesting because smell is not something that we actively think about. It's a reflex. If you observe a human watching a movie where there are things happening, you can record and see that there are certain scenes, visual scenes, that basically affect how the sense of smell is stimulated, how we basically sniff. And I think that this is interesting because this also tells us something about how to detect potentially dangerous situations and so on. So one of our recent papers really looked into whether large language models that have been trained on chemical data somehow encode the same type of representations that humans do when they speak and describe various types of smells. And this is for the purpose because we want to continue to work with multimodal systems. We see smell as one of the senses which we think will be necessary for applications where we talk about recycling, maybe garbage and so on. We want to understand whether a t-shirt potentially should be, put back for reselling, or whether it needs to actually be shredded and destroyed and so on, because it actually has certain smell and so on. So I believe that we will be seeing more of this sense of smell being more and more important. And we will be seeing, of course, more data, more multimodal LLMs, visual language action X models, more end-to-end, more real-time kind of methods. I think that this is kind of the trend that we are seeing. What I would like to see as a roboticist would be better robot hands, so going back and building things that are mechanical and that can exert all of these things that we have learned. Better sensors. I still am kind of searching for covering robots with skin, so that we are not studying only, the tactile feedback on the fingertips, but that we actually get the full kind of body contact for physical interaction with humans. And then, of course, better simulators. Okay, so I'm going to thank for the attention and open for questions. Thank you so much. Sad možemo opet na hrvatski, tako da sva pitanja mogu na hrvatskom.
Evo, Danica kaže da pitanja može odgovarati na hrvatsko, ovo je bilo malo teže. Evo, otvaram. Imamo mikrofone. Za pitanja. Izvolite. Evo, Zdenko.
Ćao.
Zdenko Kovačić sa FER-a. Pa evo, pozdravio bih lijepo Dragicu, moju prijateljicu, Danicu, prostite.
Može i Dragica, sve jedno. U Švedskoj me zovu Danika, Danika, sve sam naučila.
To mi se Draga desi, zato što je Draga pa Dragica. Da, htio sam samo započeti ovu diskusiju sa nečim što je u međuvremenu hrvatski jezik evoluirao i sad imamo i 8. padež koruptiv koji je kome i koliko.
Da.
Tako da to
Moram dodati ovoga sustavu iz 89. ako je još ovoga u pogonu. Da.
Tako, to je sve se razvija, pa tako i jezik. Da, znači, iz ovog što si nam ispričala, zaista ostaje jako puno upitnika. I danas smo prije nego što smo išli na predavanje o tome razgovarali i stalno se pitamo, dakle, umjetna inteligencija i originalnost vlastitih misli. Kao znanstvenici želimo nekako stajati iza svog rada, svojih novih ideja, a istovremeno postajemo svjedoci da ovaj AI nam to sve više i više pod navodnicima krade, jer se zapravo dešavaju stvari da čak i ta podloga koju on ima ogromnu zapravo omogućava i da generira ideje. Jer zanima me kako ti gledaš na te stvari, odnosno je li u konačnici ono što kažemo da će se programeri zamijeniti, da li će se i znanost nekako promijeniti s takvim alatima koji nam već sad polako budu na raspolaganju.
Duga priča, ako pogledamo ljudsku povijest, na koji način radimo istraživanje, promijenilo. Ako se vratimo, ne znam, nekih 300, 400, 500 godina i tako dalje. Stvari se uvijek mijenjaju i vjerujem da ono što danas vidimo, dvije stvari. Na koji način vidimo umjetnu inteligenciju kao alat koji nam pomaže da nađemo bolju informaciju, da nešto evaluiramo, da nam recimo pomognu u nekakvom kreativnom procesu gdje mi ne možemo recimo naći, gdje ni ne znamo gdje da tražimo informaciju i tako dalje. Dakle, ja vidim sve te sustave umjetne inteligencije vidim kao jedan super alat koji prije nisam imala, da tako kažem. I alate koje smo koristili, mislim od Word procesora i tako dalje, to je uvijek recimo postojalo, mada je sada malo bolje. I mislim da je super da imamo alate umjetne inteligencije, jer toliko koliko danas publiciramo, cijela akademija, nemoguće je sve pročitati. Nemoguće je sve evaluirati. Tako da ako imate nekakav način gdje pratite i da tako kažem gdje se umjetna inteligencija koristi da bi se mogli fokusirati na stvari koje su dobre, to mislim da je ok. Sad, da li sa umjetnom inteligencijom kao alatom možemo raditi nešto što inače ne bismo mogli onim tehnikama koje postoje ili na način na koji razmišljamo? Tu još nismo, da tako kažem, ako pogledamo recimo samu bazu Nobelove nagrade ove godine iz fizike i kemije, ono što je recimo doprinijelo svom tom razvoju neuronskih mreža i tako dalje je fizika, matematika i tako dalje. Međutim, i to je recimo bila Nobelova nagrada iz fizike, međutim, kemija, proteini, ne znam da li bismo bez da koristimo recimo neuralne mreže i tako dalje, da recimo koristimo to računanje i uspoređivanje i tako dalje onim sustavima koje smo imali prije i da nije bilo tog recimo da nemamo taj processing power, da tako kažem, računarsku tu nekakvu snagu, mislim da to ne bismo mogli riješiti takav problem. I onda je sada pitanje da li je to ok ili ne. Dakle, to je idući korak. I ko je onda zaslužio Nobelovu nagradu? Da li je Nobelovu nagradu zaslužila osoba koja je sklopila tih par algoritmića ili će, ne znam, za nekih 5 godina Nobelova nagrada biti dodijeljena samom algoritmu? I mislim da je to malo što me pitaš u svemu tome.
Da, to je malo ili malo upitno, je li tako?
Dvije su stvari, dakle, da li će umjetna inteligencija natuknuti koje probleme da rješavamo i na koji način da ih rješavamo. I mislim da guramo recimo tu taj nekakav horizon prema tome, da tako kažem, ako gledamo rezultate ovog kako se zove, alfa geometry, jel tako? Naći rješenje kako riješiti te nekakve probleme matematičkih olimpijada. Sad je samo pitanje, treba se pogledati da li je to svejedno trenirano. Svi oni koji su bili na nekoj matematičkoj olimpijadi znaju da ima proces, jel tako, rješavanja svih tih nekakvih problema ili zadataka. Da li je geometrija ili je, ne znam, nešto drugo, jednostavno znate kako ga postaviti i kako ga, recimo, riješiti. I ja uvijek vjerujem da sve to što smo danas uspjeli istrenirati je iz razloga što se bazira na nekakvom načinu koji smo mi ljudi istrenirali. u sustavima koji, da tako kažem, nisu kontrolirani. Problem je u tome što vidimo, mislim, reinforcement learning u Atari gamicama nađe rješenje koje mi ljudi nismo našli, jel tako? Zašto? Jer kad ja naučim nešto od Ivana, a moje dijete nauči nešto od mene, onda ja prenesem moj model. I to je pitanje koje je više filozofsko. Da li je to dobar način učenja? Dakle, nemam odgovor tome što si ti rekao, ali imam recimo jedno pitanje za svih nas. Da li moramo mi kao ljudi naći novi način učenja novih generacija koji im dozvoljava više slobode, dakle da ne prate igrati tenis ili igrati šah time što prate rules koje smo mi stvorili, nego da jednostavno nađu neki svoj novi način. I to je ono što danas vidimo. To je gdje, recimo, ta umjetna inteligencija nađe rješenja koja su totalno neočekivana, jer mi ljudi jednostavno nismo o njima razmišljali. I mislim da će to nastaviti. Sad, da li je to opasno ili ne, to je drugo pitanje. Ali ja nekako vjerujem da se mi ljudi adaptiramo svemu i novim situacijama, pa ćemo se i mi tako kako se sustavi razvijaju, tako ćemo se razviti i mi. Pozitivna slika na kraju.
Da. Hvala ti.
Hvala. Sljedeće pitanje. Evo, dok Fausto postavi pitanje, dakle ja mogu komentirati kratko samo. Potpuno se slažem o što Danica kaže, ali ja se više iskreno rečeno bojim ovih staraca koji vladaju svijetom nego umjetne inteligencije. A znamo 2-3 starca, 80-godišnjake koji su u mislima o nekom drugom svijetu, a vladaju ovim svijetom. Evo, samo, bio sam vrlo izravan.
Niste. Može engleski, da.
Da, apsolutno.
Thank you again. It was fascinating. So I was wondering on the example of the beer with one hand and how he taught the robot to pick up the lid. On one hand, could be a limiting factor for emergency behaviors that the human is teaching the robot, because at the same time that we are creating more intelligent machines, we are losing capabilities as well as humans. A simple example, my car has a camera and I get used to it. When I rent a car that doesn't have a camera, it's much harder for me to park.
Yep.
I mean, you can call me, I stupefied myself, but I gain other brain power for other things, right? So if we are always teaching the robots how to do something, how can the robots actually learn maybe a better way of doing something if their example is human, right?
Ne znam da li na hrvatski ili na engleski, mogu na oba jezika. Dobro, mogu na hrvatski ili engleski? English, prefer English, okay. Okay, no, English, perfect. No, so there are two types of learnings, or two ways we can teach, like through kinesthetic teaching, right? And this is what I said, things we don't talk about, right? Because I think that's a big problem. So when we use or train systems through demonstration, our goal is basically, we think that we are those that basically have the knowledge of how things should be done, right? And this is how we do with our kids. You either hold somebody's hand and you tell them this is how you write A, B, or C, or this is how it should, yeah? Or, as in our case, we basically use teleoperation to teleoperate the robot and then generate a behavior that results in removing the cap, right? Is that optimal behavior or is that suboptimal behavior? Is there a better way of opening the bottle? Probably, it might be. And I would say that the whole idea of reinforcement learning was developed for exactly that. You have a space in which you search, and then you test many different things, right? And then you converge to something that might be kind of like optimal and so on. That's not that way of teaching. But from the perspective of reinforcement learning, you could potentially build a system in simulation. You have a simulated robot, and then you have this physical interaction, kind of that, you try many different things. Now, there is no simulator in the world today that can actually simulate that, because there are so many things that are happening there, right? So the cap has like the small teeth, right? And you maybe don't hear it, some people do, but you actually feel it when the bottle opener comes under, so below the teeth, and kind of like, touches the bottle. And it's kind of like that thing that could be kind of a feedback signal that you have that position from which you can then start another type of a behavior. The second thing is really when the cap starts to, when you start to apply this force, and then the cap starts to deform. In many cases, right, so that's something that we haven't tried. What happens when the material of the cap changes? So if you have a metal that is very soft, or a metal that is very hard, humans would not have a problem to adapt to that, right? There are beer bottles with very hard caps, and there are those that are very soft. And you feel that after you start to apply that, and then you adapt. That, in our case, results in kind of like testing a couple of different bottles and a couple of different behaviors, so you need to give those examples. It will not emerge, as I said, by itself if the robot never kind of comes in the situation of doing that. Would it be able to learn through reinforcement learning? I suppose, yes, at some point, but then you need to have the physical interaction being very realistic so that that sim to real gap is not too big when you go to the real world.
And I guess a reward function is not human biased, right? Which is also a problem.
Precisely. That's a problem in itself. That we use human kind of, and I think that that's maybe, I didn't talk about that, maybe the bigger problem, because you build mechanical systems that are very different from humans and have sensing and proprioception that is very different from a human, but it's human teaching it. And I usually say an excellent experiment is to put a bandage on these 3 fingers, or well, on both hands, you can try that. Go around one whole day just using a simple picker and do everything you do in a day by just using 2 fingers. And you will see how difficult it is. But most of the robots today usually have only very simple grippers, right? And we try to teach them to use very kind of like neat, nice stuff with only 2 fingers. That's very, very difficult. So now you can think a little bit about that. How would the world around you look like if we had only 2 fingers? Or if we had only 1? Or none? How would we eat? Would there be mobile phones? Would we have kind of like shoes that with laces? Or would all shoes look very differently? So, vraćam se nazad. Dakle, cijeli svijet oko nas je adaptiran našem tijelu. Dakle, mi smo sve objekte oko nas napravili tako da ih možemo koristiti s našim rukama i tako dalje. Sada gradimo robote koji nemaju taj isti dexterity, nemaju jednaki broj stupnjeva slobode, a želimo ih da u našem okružju budu jednako efektivni. Nema smisla. Sad može biti pitanje da li postoji neka tijelo koje je više efikasno nego naše tijelo u ovom okružju. Možda, to znamo iz biološkog svijeta, može se brže trčati, može se više skakati, može se imati više sile i tako dalje. Ali to da, još nemamo, da tako kažemo, ono je re-engineering human. I mislim da se sada smo na početku, ja bih rekla, te faze gdje su svi naša kognitivna interakcija je sa takvim sustavima izazvani smo, da tako kažem. To je izazov za nas. Dobar ili loš, ne mogu reći, ali na neki način bit će kako se to kaže, competition. Da li smo bolji od sustava? Zbog toga, recimo, što sada u Švedskoj imamo natjecanje ko je najbolji prompter. Na primjer, to je sve. Želite naći, recimo, svaki put kad imate nekakvo tehničko rješenje nečega, uvijek pokušate nekako naći na koji način ga poboljšati ili naći nekakav način da zbilja bude efikasan kad se koristi sa strane ljudi. Ima masa drugih stvari, dakle, na koji način se takvi sustavi koriste za dezinformaciju i tako dalje i na koji način će se nastaviti koristiti za dezinformaciju i kakve opasnosti tu postoje, to je recimo jedno drugo pitanje, ali mi svi moramo doprinositi, sve što mi razvijamo, da bude explainable, da bude interpretable i tako dalje. I onda se nadam na neki način da će barem ekonomska akademska zajednica moći pridonijeti nekakvom tom boljem razvoju softvera i boljem razvoju modela umjetne inteligencije.
Evo, akademik Silobrčić, izvolite.
Kolegice, hvala vam na zanimljivom predavanju. Imam jedno pitanje. Da li ste na sadašnjoj razini razvoja ovog što mi zovemo umjetna inteligencija zadovoljni s tim nazivom?
Ne. Mislim da kad je sam naziv umjetna inteligencija je donesen, da tako kažem, mislim da nitko nije vidio ili mogao se ni predočiti na koji način će se ta umjetna inteligencija razvijati. Puno puta se pitam drugo pitanje. Koje je alternativno? Koji je alternativni naziv za sve to što se dešava oko nas? Mislim da je ta umjetna inteligencija, bilo je lako donijeti taj naziv od početka, jer recimo imali ste, ne znam, neuroscientist, cognitive neuroscientist, oni koji su željeli zbilja naučiti kako funkcionira ljudski mozak, na koji način su sinapse povezane i tako dalje. I onda je ideja bila, ok, ako mi to shvatimo kako sva ta kemija i fizika u mozgu funkcionira, onda ćemo moći napraviti mašinu i tu mašinu ćemo nazvati umjetnom nekakvom inteligencijom. Ono što mislim da je u početku, nije bio ni cilj, je na koji način će interakcija nas ljudi s takvim sustavima promijeniti. I mi smo veliki eksperiment cijelog jednog, ne znam, ja ne kažem da živimo u nekakvom Matrix worldu ili tako dalje, ali vrlo je teško biti u tom periodu korištenja samog sustava koji je vrlo avanciran i isto vrijeme gledati mozak, jer treba nam jedno 100-200 godina da bismo shvatili koji dio mozga je više aktiviran, koji je manje aktiviran. Vrlo je teško vidjeti da li, recimo, koji su ti, recimo, dugoročan utjecaj interakcije s takvim sustavima na, ne znam, ljudsko pohranjivanje znanja ili na koji način koristimo lijevu ili desnu stranu mozga, brzu ili više ili kraće i tako dalje. Ono što vidimo je da danas ne dajemo si dovoljno vremena da razmišljamo. Jel' tako? Ili da riješimo problem. Ali je pitanje da li je to zato što imamo dostup umjetnoj inteligenciji ili je zato što ne vjerujemo sami u sebe. Koji je razlog toga? Koji je razlog toga da jednostavno ne pohranjujemo nekakve činjenice jer ih možemo pohraniti na telefonu i tako dalje? Dakle, u puno slučajeva prihvaćamo, recimo, nekakva rješenja te vrlo avansirane, da tako kažem, tehnologije, jer ne moramo ne moramo pohranjivati, ne znam, podatke, puno brojeva telefona i tako dalje, jer je puno jednostavnije imati ih na telefonu. Ali da li to ima nekakav sekundarni utjecaj na to da naše pohranjivanje drugog tipa znanja nije pospješeno ili ne funkcionira na isti način jer se više ne trudimo? Ja ne znam, ja sam sjedila u autobusu, išla bi do grada i onda bi pokušala ići kroz, ne znam, nekakve brojeve ili stvari koje bi htjela memorirati ili tako dalje. Više tako ne razmišljamo i škola više tako na neki način ni ne radi. Evo kad gledam moju curicu od 11 godina, imamo problem razgovora sa njezinom učiteljicom jer jednostavno proces koji njezina učiteljica primjenjuje vrlo različiti od procesa edukacije kroz kojeg smo ja i moj suprug prošli. Da li je to bolje ili lošije, vrlo je teško za reći. Mislim da vaše pitanje je to da li je to dobar, dakle, dobro naziv umjetne inteligencije ili ne. Ne znam da li ćemo ga ikad uspjeti promijeniti. Nažalost. Ali da mislim da nas tjera da mislimo o takvim sustavima kao inteligentnima samo zato što se zovu sustavi umjetne inteligencije. Ne zato što su, recimo, inteligentni ili možda jesu, ali ne na način ne možemo mjeriti njihovu inteligenciju na isti način kako možemo mjeriti ljudsku inteligenciju. Ako postaju više inteligentni od ljudi. Ne znam što se desilo u cijelom, nekakvom biološkom sustavu kad su ljudi postali toliko pametniji od nekakvih životinja i tako dalje. O tome se možemo razmišljati. Ona optimistična Dani kaže da ako ljudi ne rade ništa loše, ako ne radimo ništa loše, ako nismo štetočine, da tako kažem, za okoliš ili jedni za druge, onda ne bi trebalo postojati ništa što bi tjeralo nekakav sustav koji je više inteligentan od nas da nas promijeni. Na primjer, to bi recimo bilo nekakvo pozitivno razmišljanje. Međutim, ona realistična Dani kaže da se to nikad neće desiti, jer ljudi će uvijek težiti nečemu ili će na neki način efektivizirati svoju interakciju jedni s drugima, ili ćete možda preći cestu ne na pješačkom prelazu, ili će sve te stvari gdje onda neko taj nekakav sustav koji je više avanciran može reći tu si pogriješio i zbog toga moraš biti, kažnjen. Nažalost, nema boljega za reći.
Ja mislim da mogu raspravljati mi do 5 podne.
Ali nemamo vremena.
Ja predlažem,
Ali nemamo vremena, pa onda ja svima kažem ko ima pitanje, pošaljite mail.
Predlažem da polako zaključujemo. Ako ne je baš neko vrlo, vrlo ekstremno važno pitanje, puno pitanja moglo biti, ali i danas neke slajdove preskočila i kako je rekla, pokušat ćemo da ne bude sljedeće nakon 10 godina, da bude ranije, pa onda ćemo opet biti prilike zapitati. Danice, ja ti zahvaljujem.
Hvala.
Baš mi je bilo zadovoljstvo. Hvala svima što ste došli.
Hvala.
I što drugo reći, osim baš nam bilo lijep petak popodne.
Hvala puno. Ok, hvala. Ništa, onda idemo samo ću pozdraviti.